All right, guys, we're going to talk about free response number 28, no using your calculators. It says, picture below is a table of values that represents the graph of an exponential function, and it gives you the form that they are discussing. And you're using the table to answer the questions below. So I want to address the first one for you. Says describe the behavior of g of x as x approaches negative infinity and positive infinity using the words increasing, decreasing, bounded, or unbounded. So really, you already know what increasing and decreasing means, but let me just talk to you a little bit about bounded and unbounded. It's actually quite a simple concept. If you are bounded by something, it's like a boundary, right? So that means that there's there's a limit, there's a number that's keeping you from being free. And unbounded just simply means there are no bounds. You keep going forever and ever. So if we use the word unbounded, then that would indicate that you are going towards infinity in math. If you're bounded, then that means you're approaching some number. So let's take a look at the end behavior. I'm going to work with you on A because it's new language. And then the rest of these, go ahead and answer. Well, I'll have you answer B, C, and D after we discuss A. So what we're going to do is we are going to look at the left end behavior. So what's happening on this side of the graph. So you already know that exponentials have only one end that have a horizontal asymptote. So if we look at the left side and compare it to the right side, we can see that the left side is going to negative infinity. So that is going to be decreasing, right? Because the y values are getting lower, and it's unbounded because it's going to infinity. Whereas if we take a look at as x goes to positive infinity, we are approaching the number 2. So let's take a look at what we can do with this. So here we go. As x approaches negative infinity, the graph decreases without bound. And as x approaches positive infinity, the graph increases, right? Look at the y values. You're going from 0 up to 2, or from negative 510 all the way up to positive 2. So it's increasing from left to right with a bound, right? Because remember, a bound is like a boundary. Address any questions you have on that academic vocabulary. I feel like it's pretty straightforward, but nonetheless, go ahead and address any questions. Go ahead and answer B. All right, so is it going to be growth or decay? Well, if we can analyze our end behavior, if we on the left are going from negative infinity to all the way up to 2, then that would indicate growth. And just exactly that. As x values get larger, the graph of g of x increases. All right, C, give me the value of C and also explain your reasoning. Okay, C is going to equal 2, and that is just simply for the fact that that's going to be the horizontal asymptote. But this is just the idea. So here it says, as x approaches infinity, the graph of g of x exhibits bounded behavior, meaning that the values continue to increase but do not approach infinity. As x, this is just the idea. You don't have to have this written down, okay? This is what the inadequate explanation would indicate. As x approaches infinity, the values of g of x approach y equals 2, which means that y equals 2 is a horizontal asymptote. And in the equation, and again, it's the formal equation they provided at the beginning of the prompt, the value of c represents the horizontal asymptote. All right, go ahead and answer D. All right, so hopefully you are able to answer A. Let's take a look at how we're going to explain our reasoning in this. All right, the sign of the value of A in this equation determines if the graph of the exponential function is above or below the horizontal asymptote. Since all of the g of x values are less than the horizontal asymptote of y equals 2, then the graph is below the asymptote, which means the value of a is less than 0. All right, on E, state the domain and range. Okay. Hopefully you are getting really good at domain and range, and please address any questions.